Hello, 5th grade math students. This is Chapter 5.4, Real-World Problems Using Algebra. We're going to begin by writing an addition or subtraction expression for a real-world problem and then evaluating it. Our first problem goes like this. Tyrone owns Y MP3s. John has 3 times as many MP3s as Tyrone. Then, John buys 7 more. How many more CDs does John have than Tyrone? We begin by writing an expression. We know that Tyrone has Y MP3s. John has 3 Y MP3s. Then he buys another 7, plus 7. So the number of CDs that John has is 3Y plus 7. So how many more does he have than Tyrone? Well, Tyrone has Y MP3s, so we need to subtract Y away to calculate how many more MP3s John has than Tyrone. 3Y minus 1Y gives us 2Y plus 7. So John has 2Y plus 7 more MP3s than Tyrone. Part B of the question is, if Tyrone has 25 MP3s, how many more MP3s does John have than Tyrone? Okay, so from part A, we know that John had 7 plus 2Y more MP3s than Tyrone. So what we need to do to solve is substitute in 25 as our value for Y. So let's go ahead and do that. 7 plus 2 times Y, which will be 25, equals the number of CDs more that John has. So following PEMDAS rules, we'll have 7 plus, we'll multiply first, 2 times 25 gives us 50. So John has 57 more MP3s than Tyrone. Try this problem on your own. Ray has $M. Ben has $15 more than Ray. So how much money do they have all together in terms of M? So if you're going to write an algebraic expression that shows Ray plus Ben equals total, what would that look like? Then part B, if Ray has $75, how much money do they have together? Press pause while you work, and when you come back, we'll work some problems with multiplication and division. All right, now let's write a multiplication or division expression for a real-world problem and evaluate it or solve it. So Salma has X dollars in her wallet. First, she buys a shirt for $15. She then spends the rest of her money on 3 movie tickets. The first part of our problem asks us to find the price of each movie ticket in terms of X. Okay, so let's begin with what we know, which is that Salma has X dollars. She spends $15, so we're going to subtract that away from the X. She then buys 3 movie tickets. So she's going to spend whatever is left after she takes 15 away from X, divided by 3 on each movie ticket. So we'll set that up by putting a parentheses around X minus 15, because that's the money she has left, right? And then we're going to divide it by 3. So the answer is X minus 15 divided by 3 equals the price of a movie ticket. Okay, let's go on to part 2. Part 2 asks us, if Selma had $39, what is the price of 1 movie ticket? So we're going to take the equation that we created before, which was X minus 15 divided by 3, or X, the starting amount of money that she had, minus the $15 she spent on the shirt, divided by 3 to give us the price of a movie ticket. And we're going to substitute in that $39. So $39 minus 15 divided by 3 will equal the price of the movie ticket. Following rules of PEMDAS, we'll do whatever's in the parentheses first. So 39 minus 15 will give us 24 divided by 3 which is 8. So each movie ticket cost $8. Try this practice problem. A man has Y dollars. He withdraws $200 from the bank and then spends half of his total money on groceries. So part A asks, how much does he have left in terms of Y? So if we take what he started with, add the $200 he withdrew from the bank, and then divide it in half to show what he spent on groceries, what will he have left? And in part B, if Y equals $80, how much money does the man have left? Press pause while you work, and when you come back, we'll move on to one final idea. Let's finish up Chapter 5.4 by using algebraic expressions to compare quantities and to solve equations. Andy and Cathy each have some pencils. Andy has his pencils in 4 boxes. 3 of those boxes have the same number of pencils, which we'll call P. The 4th box has 3 fewer pencils than the other 3 boxes. Cathy has 2 boxes of pencils. Each of her boxes has P pencils, and she also has 13 extra. Our first step here is to write an expression for the number of pencils that Andy has, and then to write an expression for the number of pencils that Cathy has. So let's start working with Andy's pencils. We'll write his in red. So Andy has 3 boxes with P pencils each. We'll write that as 3 times P. He also has another box of pencils that has 3 fewer pencils. So we can assume that that box started with P pencils in it, and then we subtracted 3. So now we can combine our terms to get our final expression. 3P plus 1P gives us 4P minus 3. So Andy has 4P minus 3 pencils. Now let's write Cathy's expression. Cathy has 2 boxes of pencils, each with P pencils. So 2 times P. And then she has 13 extra pencils. So Cathy has 2P plus 13 pencils. The next part of our problem asks us to write an inequality to show who has more pencils if P equals 9. So if there are 9 pencils in each box, who has more? Okay, so let's first solve for Andy. Andy has 4P minus 3 pencils. 4, when we substitute in our 9, minus 3. 9 times 4 is 36, minus 3. Andy has 33 pencils. Now let's solve for Cathy, if P equals 9. So 2P plus 13. We substitute in 9 for the P. 2 times 9 gives us 18 plus 13, which equals 31. So Cathy has 31 pencils. So if P equals 9, we'll write this inequality. 4P minus 3 is greater than 2P plus 13 when P equals 9. We simply took the equation for Andy and said it's greater than the equation for Cathy, which is true when there are 9 pencils per box. And here's the final portion of this problem. For what value of P will Andy and Cathy have the same number of pencils? So if there are P pencils in a box, what does that number have to be for Andy and Cathy to have an equal number? Okay, so we're going to set this up as an equation. We want Andy to equal Cathy. So we're going to substitute in the expression that tells us Andy's pencils, and that's 4P minus 3. And we're going to set that as equal to 2P plus 13, which is the number of pencils that Cathy has. So now we simply follow the procedure for solving an equation with a variable on each side. We'll begin by moving our negative 3, by adding 3 to both sides to get rid of that negative 3. We can't subtract 13 from negative 3, so we're going to add 3 to 13. So our new equation will be 4p minus 3 plus 3 equals 2p plus 13 plus 3, because whatever we do on the left side of the equation, or the equal sign, we have to do on the right. So this now becomes 4p equals 2p plus 16. Okay, now we need to get all of our variables on one side. So we're going to subtract 2p from each side. 2p minus 2p plus 16, 4p minus 2p. Okay, so now we solve to get 16 equals 2p, because 4p minus 2p is 2p. Our final step will be to divide each side by 2, so we can isolate that variable p. Sorry, we've run out of room, so I'm going to solve it over here to show you that p equals 8. So if there are 8 pencils per box, then Andy and Cathy will have the same number of pencils total. 4p minus 3 would equal, let's see, 4 times 8 is 32, minus 3 is 29. So if p equals 8, Andy has 29 pencils. And let's try the same thing for Cathy. If p equals 8, 2 times p is 16, plus 13 is 29. So if there are 8 pencils per box, Cathy also has 29 pencils. And here's your final practice problem for this video. Lenny has 2y minus 7 marbles, and Max has y plus 9 marbles. Write an inequality to show who has more marbles if y equals 18. So remember, you'll end up with a statement that either says 2y minus 7 is greater than y plus 9, or it might say less than, or it might say equals 2, but probably not, because it's told you to write an inequality. So you're going to fill that in with either a less than or a greater than symbol. And then for part B, for what value of y will Lenny and Max have the same number? Remember, you'll begin by setting up those two equations as being equal to one another, because they're going to end up with the same number in the end. Then solve for your variable. Do your best to work these out. Don't worry if you get stuck. We'll do lots more problems like this tomorrow. Thanks for your hard work, and I'll see you then.